So I'm here with Dorlor, the CEO of ScyllaDB, and we're here to talk about, all the fun stuff that they're doing over there, and also talk a little bit about his journey and why he started the company. So, Dor, how are you today?
I'm great. Thanks for having me here, and looking forward for our chat.
Okay, great. And so I know like your background is very development centric. So did you start as a developer? I see you were an engineering manager and you were deep into the Linux kernel for a while. So how did you get your start?
So I'm an engineer. I went to kind of the Israeli Technion Institute, which is like our MIT. And actually it's nice because I went there in order to, it's the best institute in Israel, but I went there in order to network with people. And it really worked out well because I met there a bunch of people that I worked with in my first startup, and it didn't go that well. It was a terabit router company. But,
okay.
What really went well is that I have friends. It goes back 20 years back, so have lots of friends from that endeavor. And currently, happened to be that I have 3 people who went with me to university for first degree and master degree there, who are at Scylla, the VP of Engineering, the VP of Product, and another really good developer. All we learned together. So,
and that's always
kind of, my background.
And that's a really good way, right? So once you start to know and trust someone, we see that a lot where you want to work with people who you can trust, who you know, and who have good knowledge and can work together. So once you build that rapport, it's a very good thing to be able to bring those people along with you. And, going from that startup, you ended up at Red Hat and you actually worked in the kernel virtual machine and worked as a platform virtualization director. I mean, how did you kind of jump into that open source space with Red Hat? I mean, that seems like an interesting move from an engineer having your own startup. You kind of jump into Red Hat for a little bit. What was that like?
So initially it wasn't my own startup. I joined as an employee and I coded and did a bunch of stuff. And I did try to have my own startup back then in 2003, or 4, but I didn't have the credibility to get money. So I had to wait until the KVM project was successful in order to be able to easily get funded. So KVM was helpful, but the way we got into KVM was kind of more of eventual. I joined a company called Kubernetes, and with its name, it was supposed to be a network type of device. And we pivoted. We had to pivot 3 times. It was my school for pivots. And the second pivot was an idea that Avi, my current CTO, brought. It was really super cool, nice idea about lockstep virtual machine execution for AJ with the Zen hypervisor. And we hit a wall with that project. It worked, but wasn't performing enough. And we had to pivot again. And then this is where Avi came up with a really novel idea how to re-implement hypervisor from scratch using the CPU technology. And that was the KVM hypervisor, which started to boom pretty quickly and was part of the Linux kernel. And 2 years after Avi scratched the idea, Red Hat acquired the company, and we spent there 4 years.
Okay, and so that's how you ended up at Red Hat. And, so you were at Red Hat for 4 years, and then you had an itch to do something else. So going from, working on a hypervisor, working on the KVM to databases, what inspired you to jump into the database space? That seems like they're kind of in the infrastructure space, but it is a jump.
It's a jump. It's a jump, and I can elaborate how it happened. Basically, being able to accomplish something like the KVM gives you a lot of sometimes too much confidence, and sometimes in order to jump into the database, to be honest, you need to be more of a fool than an expert, because you may not know how big is of endeavor it is, so you're feeling too confident and you jump on it. But so just to be honest, that has been the case. Now, especially when a similar way to we were new to hypervisors at some point too. It came through a pivot, and we learned the domain. This is how we were new to databases. And originally we founded this company not around databases, so because we weren't expert in database. What we wanted, the company was founded with the promise of developing a new OS from scratch, including our own kernel. So back in late 2012, we identified that everybody run just one workload inside their virtual machine. So like you get a full-fledged OS and you just run a single app. It doesn't make sense. So we developed a new OS called OSV. It's a unikernel. I'm sorry, definitely not a unicorn.
Not a unicorn.
It didn't succeed. And the target was to optimize an OS for just one task and to load it into the kernel space. So we developed that. It was an open source OS. That's how the company got started. But at the time, Docker started to emerge, and Docker wasn't there when we did it. And Docker was more of a mainline standard to package and run virtualized applications in a different way. So Docker succeeded a lot. We haven't, and we needed to pivot. And one of the workloads that we wanted to show improvement was the Cassandra NoSQL database, because Cassandra was successful back then. It was around the year of 2014. Cassandra was quite successful back then. And we wanted to show the value that we give to Cassandra in terms of speed. And while our OS, when it used to run an application like Redis, we managed to boost Redis by 70%. Because we had our own specialized kernel, and the application was living in the kernel's place, and we had our own network stack, our own TCP/IP. So it was really beneficial for a super simple and trivial application like Redis. In the case of Cassandra, it was the opposite. We didn't really move the needle, and something really looked wrong for us. First, it's like Java is a great language for management application, but a pretty wrong choice for infrastructure. It's just a big layer between you and the hardware. That's exactly the opposite of what we were trying to do with that OS, and also in the past. So that's one thing. And also at the time, Google published a Cassandra benchmark, and they used 330 virtual machines to get 1 million operation per second database operations. And we left Red Hat when the KVM broke the world record of 1.6 million IOPS operation with a single VM. Now it's pretty apples to oranges, because the IOPS is file system and database IOPS with replication, but still it's 1 to 330. And since we needed to pivot, we did additional market research and technology research, and we decided this is a big opportunity. The API and all of the promise of Cassandra looks really solid, and it has great things in it. Like it's the best platform with high availability and disaster recovery. But it's like in terms of scale, all of the nodes are homogeneous, and we really like the model. But we thought if we'll bring all of our experience, not in database, that we'll take a good database design from Cassandra, which is built on DynamoDB and big tables, and we'll just implement it in the way that we used to implement things in OS and KVM. Then we'll bring a lot of value. So that was late 2014, and that's exactly what we do since.
Yeah, and what's really interesting is I just had another podcast with Karthik Raghunathan, who was one of the key developers at Facebook of the original Apache Cassandra, right? So, and I asked him what if he could go back and do anything again. He said he wouldn't have used Java, and so obviously, there are some limitations with Java and the Cassandra, but it's really interesting that you brought a lot of the OS optimizations and techniques that you use to optimize the KVM and the kernel directly to the database. that's a very unique pathway because many of the engineers who I've talked to, especially from companies that have designed and built databases, they come from the database space. They're not necessarily OS engineers. And so, what are some of, you mentioned you had to pivot a couple times, but was there anything that you found that, you felt like, oh, if I only knew that when we started, it would have been way easier. This would have been a way easier project for us to get involved in.
It's not just one; it's plenty. Yeah.
Always.
And sometimes it's not just about us. I think it's also learnings that other vendors and even entire communities undergo, like things that are not purely in the database space, like MapReduce. Initially, you think, "Oh, what a great idea," but then it's more challenging. So in our case now, for example, we're doing a huge change right now. So so we mimic the Cassandra functionality, and we recently added the DynamoDB API. I think maybe the DynamoDB API triggered a lot of things to it. So first, many times it's good to be a latecomer, because as a latecomer you can come late and review everybody's mistakes and take the best and try to improve when. So you don't necessarily need to be the smartest. You just get the experience of others. So we're trying to do exactly that. And for example, with change data capture, so Cassandra basically doesn't have a change data capture. They just kind of a piggyback on the commit log, but it's a horrible solution. It doesn't have. It doesn't take in mind replication, and it's super hard to consume it. And on the other hand, DynamoDB has a pretty good stream processing, Dynamo Streams, which is a change data capture, and they did it the right way. And you can you can consume it in a fully replicated way, and you get to also get to decide whether you want the key, the data, the previous data. So we took the Dynamo idea, bolted on our implementation with improvements. So our change data capture is a table. So since we came last, we got advantages because of it. But for example, something else that we do now, which is a completely big revolution, is we're re-implementing basically everything using the RAF consensus protocol. So traditionally we mimicked the Cassandra eventual consistency, which of course is a trade-off. And I always tell my engineers that when they go to implement the best solution, I tell them, go back to Cassandra. If you take a weird concept like eventual consistency, we wouldn't have invented eventual consistency because it looks somehow wrong, but it has a lot of benefits too, in terms of high availability and partition tolerance, all of that. So we get to benefit of it. But now with by implementing Raft, we'll be able to allow everything to be consistent without performance penalty. So that's a huge change for us. It's also super complicated in the way we do sharding, and we kind of do it very late in the game, after 6 years of development. And this thing goes across the board. It's not just the consistency that we provide to the end user, but also basic things like topology agreement and schema-based transactions that are not in Cassandra or not in Scylla. Now, after we have lots of experience, and now finally we have also more time after we managed to be on par with the API, now we can take it to the next level. But if we would have started with this knowledge, like going back to 2014, we would have started with it to begin with.
And I think that that's one of the interesting things that you see. there's a rush often to develop the new cool thing, the new feature. And there's definitely benefits when you are the first to have something, but there's a lot of drawbacks as well, because a lot of times you're blazing the trail, and that can open yourself up to, bugs or, reputation problems. There's a lot more risk. And it seems like, being a little bit behind and focusing on the best solution enables you to ensure that the features that do come out are more polished and ready to go. I mean, is that what you're seeing as well? Like you're getting things that, oh, this is how this other place did it. They used Raft, so let's do that because they've proven that it works. They've solved that problem. Is that kind of how you work from an engineering perspective? You look at those?
It was less kind of it was less a decision that we've made. Normally, it was more of a lack of choice because we came not just a little bit behind, but we came after everyone had their own NoSQL solutions, and they were relatively mature. So we have to just rush and go and implement everything. And initially, it's very helpful because you don't necessarily need to make a lot of decisions. You need to make decisions in terms of the underlying implementation, but not the API. So it's relatively easy, and it allows you to move fast and also to do things better. But now that we're kind of accomplished the API of Cassandra and the API of DynamoDB, now this is where it gets complicated, and we create new APIs, and that's a harder job, to be the first person that ever toys with new features. But it's also interesting and cool. So.
Oh yeah, definitely. So you guys have gotten a lot of press around some of the performance that you have done. I've seen some numbers that you've thrown out there on the scalability and how you've helped certain customers achieve that. It seems like scalability and performance is often desired, but it's often becoming a lost art in a lot of databases because people are more comfortable just paying more and trying to use the easy button on the cloud or wherever, like, oh, let's just add more hardware. Let's add more. So maybe tell me a little bit about, like, from a performance perspective, what are you seeing in the market? Like, the customers that you're showing on your website and that you've done press releases on, they've seen some pretty staggering improvements in performance. Has that focus on performance done well for you? Is that something that you're seeing the market start to look at? Okay, performance does matter again.
So it all started with our approach was all started with performance. Yeah. So we're very focused on performance, but it's not just performance that we focus on. So I'll split my answer to two. Okay. Performance matters, but it also needs to be it's not everywhere. If performance doesn't matter, like everywhere where users have a low amount of volume, I tell them go ahead, use relational database. It's not a big data problem. Go ahead and solve it with a better tool that offers better flexibility. Scylla, as much as we try to do tons of good things, relational services are better for smaller databases. If they can be a good match for big data sets, even better. But they cannot, so they break at some point. So if you do need, in many companies today, since data explodes all the time, then they do need to have to deal with large data sets. Sometimes performance can be throughput, can be latency, and can be very large data volume. And some databases cannot scale at all, or some databases can scale, but it becomes super hairy to scale them, and you need to maintain them a lot, and this is where they break. And sometimes it becomes too expensive, and sometimes the whole project won't have any meaning if it's so expensive. So performance solve you this performance and scalability solve you this whole range. but we're really not trying. We did start with a performance goal, but because we wanted to improve a pretty good standard as Cassandra or as DynamoDB. But it's definitely not just performance. So we take a lot of pride about simplicity. So Scylla is performance oriented, but in order to get it, the whole idea is to have great out of the box experience. We have a shell script, which is the installation tool, that you just run it and it automatically configures all of the right kernel settings, all of the right OS settings with one command. It creates a RAID device with the right striping. It configures NTP. It does everything. And we even measure, that tool runs a mini benchmark in order to evaluate the disk performance, because one of the benefits of Scylla is not to queue on the file system or on the disk, do the queuing within Scylla, so we can control and prioritize what's low latency I/O and what's not latency sensitive. So our installation tool measures the disk performance. So we try to, and it's just one command that you run once and that's it. So simplicity matters a lot. I relate to it a lot, and also functionality, like the CDC is like super beneficial, and you can hook Scylla to Kafka super easily, etc., etc. And there's other features that are really important. It's not just about performance.
Yeah, and we've seen, like, with the growth of the cloud, a lot of the cloud growth is because it's easy, right? People want to click the button and just have it work and have it set up and not have to worry about it. And the more you have to adjust by hand, it satisfies the engineers to have to do that. But we're seeing more developers not want to have to get down to that low level, which is a far cry from 5-10 years ago. And even when you started and when you worked at Red Hat and when you were doing KVM, it was probably a lot more hands-on, in the weeds, in the settings. So I definitely agree, and I've seen that growth in the easy side of desire to have things just kind of be the point and click. Now, I'm curious, as you're talking with users and customers, what are you start to see as the trends that they're experiencing that you're helping them with? Like, where is the market going? How is it evolving?
So it's pretty much relates to what you said about cloud, and cloud and database as a service is super beneficial, and people need that. And it's one aspect is the ease of use of it, but also the core infrastructure needs to support that. So if a cloud user would expect elastic deployment, and this is a big trend. Yeah, you want the distributed database of yours react dynamically to load, whether it's Black Friday or whether it's every day that the night has less amount of traffic, and over the day there's more, and ideally the database will react to it. And there's lots to be done, both in terms of ease of use, but also under the hood, because if you need a flexible deployment, you'll always be moving terabytes of data around. And that's, again, goes back to having a perfect scheduler that can schedule low priority queries on top of just streaming of terabytes of data that happen all the time. So one trend, so it's important. One trend is database as a service. Another very good trend is Kubernetes. And like 2 years ago, like people wouldn't do stateful applications with Kubernetes. Now it's possible, and many go to Kubernetes route and use Scylla with Kubernetes too. So that's
are you seeing growth in that space? So you're seeing growth in the okay. We're seeing about a third of the users out there starting to do that, to use it for database production workload. So it's not the majority yet, but it is moving in that direction. Yeah, to make it easy.
I definitely agree. No, not sure it will be the majority, but especially with database as a service will be the majority. Maybe not. Also, maybe not today. We see a high growth of it, but it will become the majority for everyone, and there will be users who want to manage their own, and large portion of it will be Kubernetes.
Yeah, and I know you have your own cloud offering, your own database as a service, the Scylla Cloud. Is that where you're seeing, like, have you seen the movement more towards that than, the on-prem? Is that where you're seeing your trends?
Yeah, but by far, so some of our kind of the non-managed solutions, Scylla Enterprise or Scylla Open Source, many times people manage it on their own but run on the cloud, and sometimes they insist to run it themselves, and it's fine. We provide all of the options, but the fastest growing service of ours is Scylla Cloud, which is a database as a service. So that's, and indeed it makes sense, because it's, no matter how we'll simplify distributed database management, it's still complicated, and you need to be aware to wait for node failures, data center failures. Recently, OVH had a fire in one of their data centers, and we have a customer there that wasn't, nothing happened because Scylla is prepared to, but it's hard to get it right and to test it, and some people don't do backup at all. Some do backup but don't test the restore. So just buying something, especially for low scale, if you have a high scale, you may be able to have your own engineers who are going to manage it, but for low scale, it's impossible for a small company or a small project, can be within a big company, to invest all of the right time to make sure that their deployment is flawless. And it's just easier to buy from a service.
Absolutely. Well, Jor, I want to thank you for joining me today, and we're just about out of time. I do appreciate it. This was a great conversation. You've been doing a great work over there. I've seen, a lot of good press. I've seen, a lot of users who use our products have also tested yours. So really excited to see your growth, and congratulations on, pivoting and getting to the business where it is today.
Thanks a lot. Thanks for having me, and also keep on doing a great job with Percona.
All right, will do. Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.